and H are both the same. Here, of course, S and H are different, the size of the window and the hopping slide. So, which is why, I mean, these are very common streaming data concepts. I strongly encourage you go through books like Designing Data-Intensive Applications by Martin Kleppmann. He actually coined all these terms, tumbling window, hopping window, etc. And then there are multiple others, but then session window is also something which makes sense. It actually tracks when the window would close based on inactivity. So it's very good to understand if your user had logged in, when did the user logged out, and what was the duration. So it comes in very handy for that. Flink supports all these windows. Let's look at some code. I wish I could have shown you the demo, but then we have to stick with the format. So normally what happens is you would have these topics. So for here, I have my topics, transactions, and customers. These Kafka topics are converted into Flink dynamic tables, as I told you, automatically. And I could actually do a join, where I could do distinct transactions from transactions and then join it on customer ID and put it on a sync. And I want to see how many customers did what transactions, etc. If you can't follow the code, that's my, I've done a 6-part series on Medium, paywall free, where I introduce you to Kafka and PipeFlink, and this is part of that series. So you would get that code. Look at the code. What I did was, if you remember, I showed you the image. I have my IoT sensor. So I created a sensor, I created a Kafka topic where all my sensor data is going. I created a Flink dynamic table, as you might see, that it has a connector Kafka, and the topic is sensor.readings. It's running on my laptop. And then I created this table which exactly matches the schema of my message format, right? And then what I do is I execute this SQL, and it gives you a table which now you could query with Flink SQL. Now, what you could do is I could actually write a window operation. If you look at, so in my last slide, you saw that my table is created, and that's the sensor readings tab. Here I put the tumbling window, 30 seconds tumbling window on the processing time on which server it's happening. And I group by the device IDs. And what I really want to select is the charge consumed, which is like a sum of one of the values. So every 30 seconds, I would get like as many device ID grouped, distinct device IDs, and the charge consumed by those devices every 30 seconds. It would give me like a good understanding of how my battery is operating, state of health of a battery. Can I do the same thing with Flink SQL? Absolutely yes. So it both produces the same explain plan as I told you. So this is the same thing which I did with the Python table API using Flink SQL, ANSI SQL compliant. And here I'm grouping by the device ID, and I'm doing a sum of one of the parameters called ampere hour as charge consumed. That's my Kafka PipeFlink getting started. So if you missed it, you could have a look. It would get you started. And these are all open source frameworks. No need to pay no need to pay any money. You could just run it on your laptop, Apache Kafka and Apache Flink, and you could get started. That's the Flink community. We are actively looking for committers. So if you really think that this is something where you could commit, by all means join our Slack. Very, very vibrant and helpful, friendly kind of a group. That's me. So do I have like 5 more minutes? Yeah. So that's me, and that's the end of the talk. If you have any questions, love to answer. We still have 5 minutes.
Thanks for the talk. Let's thank the speaker. We have a few minutes for questions, comments. Anyone here? I'm happy to see a lot of Kafka talks because we used it a lot. And yeah, so I haven't used Flink a lot, but and I won't be a contributor to too many other things to do, but I'm very grateful for your work on this.
Thank you very much. Yeah. Thank you very much.
Any further questions? No, then let's thank the speaker again. We have 3 minutes to prepare for the next talk. Is this your phone?
Oh, that's mine, yeah.
company, when we have this case that we get a bit early, then they say, you get 5 minutes back. Make great things in these 5 minutes. Yeah, let's wait for the round until some others are coming around.
But you know, when you said get ready, I was like, oh, so I'll start preparing to talk now.
Yeah, the vector search is now everywhere, right? Without that, you cannot go and sell anything anymore. It's like inherent part of the AI requirements now.
Yeah, you know what's statistics, what's numerous data support.
I will show you like 10 minutes and 5 minutes before.
But after the there was an audience, so excuse me.
This is one of your KPIs.
I wasn't presenting to an angry room. FOSSASIA in Europe. She gets it early enough, so maybe she's actually watching.
The live stream. We can sabotage the live stream if you want.
No, I'm just waiting for it.
Any problem? Yeah. Where's the the clip-on mic? That one is fine. Yeah, so.
This one is fine. Okay. Get my best singing voice out. No, I won't inflict that on you. Nice and consistent. Excellent. I didn't press buttons. Buttons are not toys. Or maybe they are. Yeah. Anything quick as an intro. That's fine.
So, yeah, we have 1 minute more, so can use this for the introduction. So Daniel Black from the MariaDB Foundation, he's a common visitor at our conferences, so we are very happy to have him here. And he will speak about vector search. I just asked him, well, it's one of the main components nowadays a database has to provide, because otherwise, like all the AI guys will get crazy without vector search and something we cannot do anything. So let's welcome the speaker, and I look forward for your interesting talk.
Thank you, Norbert. Hi, I'm Daniel Black. I'm from the MariaDB Foundation. As mentioned, I'm talking about vector search database. So MariaDB in their 11.7 release in 6 months ago actually came out with our first iteration of a vector search database. So this is now GA at 11.7, and 11.8 has some minor improvements on that, but we'll get to the roadmap of what's to come next and see how long this projector starts. But hey, the side ones appear to be working if they fail. So vector search, as is probably already covered, is the technology behind schematic search and image search and RAGs and music search underneath, as you probably know. And so what happens in a vector search database is information in the form of an image, a text, a document is transformed using a content embedding into a vector. The vector is stored in the database, and to search it, we actually put input data from the user through the same embedding transformation, and we get an input vector out. And after that, it's a responsibility of the database to just search for which vector is closest to each another vector in the database. So the database itself doesn't actually know about the model at all. You know, there are trickier problems as well. So a vector is just a list of numbers. Depending on the model, it's got between tens to thousands currently in the length of the vector, and it's the model that will actually determine this. So the embedding, the critical aspect of models, as you know, is that, you know, similar things will become in a close to each other in a vector sense, and then after it's the embedding's not done in the database, and it's the job of the database to actually find the closest one. Now, the absolute closest, you know, object to another, a vector to another vector in a database is a really hard problem. It would actually involve, you know, a full table scan and to actually work out the distances. So what we get with vector search is an approximation, which is a novel concept for a database that's sort of typically always, you know, precise answers. However, that's a problem space, and that's what we implemented. MariaDB does a fairly common thing and does hierarchical navigatable small worlds. We did do a minor modification to the algorithm that we found out gets around like some local minimum problems, i.e., you know, you start searching an area and it's like, it's a minimum, but, you know, it's not a minimum over a big area, and we've got some, on the models we've tried, some good outcomes of it. The algorithm's a in-memory algorithm, so, you know, once it goes beyond memory size, you know, it performs horribly, and that's just the nature of the algorithm. It needs everything in memory. As usual, this model is, you know, a optimum trade-off between speed and precision, which is what, you know, people want their answers quickly, and they want a reasonable level of precision, and they're willing to sacrifice a little bit on both, and how much depends on the application. In an SQL sense, thanks for the SQL introduction before, that what tends to happen is we get a embedding as a vector type. The vector's got a length in a typical SQL way, and that's the number of elements in the vector, and there's an index on the vector. So this is all pretty standard as far as the SQL goes. If we're using something like OpenAI, what we do is we actually use the Python libraries there just to import it. We do an API call out, and we get an embedding vector back, and that's all it is as far as the Python goes. When we do a search, we do the same thing in reverse. We get the input vector, we get the embedding. The embedding's a set of numbers. This is inserting. So inserting into the database, and we've got a vector from text function that does all the conversions. So all pretty standard SQL on that. The search, we take a user input through the same embedding algorithm, and we do a select from the table, and we order by the vector distance between what the user sort of passed in that vector to what the embedding column on the table was, and do a limit. And this is how we get like the 5 closest vectors in pretty much the same way as any SQL query has been since COD invented it. If we're using a framework like Llama Index, there is a MariaDB vector option. We pass a set of database parameters, which are pretty standard, and then we've got a hint that sort of says the vector column is such and such, and it's a type and the length of it, and thereafter you pretty much use it the same as a vector store in Llama, if you're familiar with that sort of thing, which honestly I'm not, but hopefully someone is. That's why they invented them. LangChain, similar thing. We import the Python module, we create a vector store, pass a series of parameters. There is a vector distance strategy as a cosine or Euclidean in a typical way. The embeddings are part of the arguments, and same with the length. There is whatever models you use in OpenAI. For tuning, what MariaDB went for is, if you look at like the hierarchical neighbors small worlds algorithm, there is a bunch of tuning parameters there. So what we've done is we've minimized them down, i.e. this is the entire list of the tuning parameters available in MariaDB on that. And we've done this so it's nice and easy for the users to get a grasp of, and sort of hides the complexity. At the basic level, there is a distance algorithm with Euclidean or cosine. You'll know when you're using the model as to which one should be actually being used. We've got an M value. It's got a hard limit of 3 at the low and 200 at the high. But realistically, as we'll see in the benchmarks later, 8 is about a good value. If we go up to 32, that's probably about the realistic maximum, but it can depend a little bit on the algorithm. What's important to note actually about these is the M value is what PG Vector and other algorithms might actually use as an M value, and the EF search below isn't actually always portable across it. So if you switch databases for some reason, don't assume what was there used before is exactly the same on the new implementation. EF search is like the number of search items into the index that we're actually going to do to get the results, and we'll see the impact of that a bit later. As mentioned, it's an in-memory database, therefore it's got a size. If you go beyond that size, it starts swapping, that's bad, and it slows down significantly. So there is a cache size parameter, stay within it and you'll be all right. So F and M, so we have a choice in vector search as to we do slow and precise or fast and imprecise. And the other trade-off we have is when you're actually building an index, you can build it really fast and have a slow search, or we can build it slowly and get a faster search. And that's just the nature of the algorithm trade-offs. As far as the parameters go, the EF search only affects the search as far as to how deep we go, and the default M actually affects the search in the right. So with these two parameters, we've got a good control over the trade-offs between precision, speed, and also the consequent building speed associated with that. As before, I mentioned that the M and the EF search values are actually different from PG Vector or others, and what typically happens if you're using MariaDB, that you'll be using a lower value of M than PG Vector. The benchmark I'm quoting from is Mark Callahan's benchmark. He's been doing benchmarks for years, and there was a bunch of hardware at Hertzner that you can read just as well as me on that. So this was an ANN benchmark that was done for no particular, there was probably a reason, but it was a common one that there was a lot of implementations from PG Vector, from Quadrant that I'll mention, that have actually contributed not only the tuning parameters, but the mechanism to actually run the tests, and that's what he did. Noting a few things from actually the full slide, I'm just going to abbreviate on these. MariaDB uses 16-bit integers rather than a full float 32 to actually do the search. PG Vector uses a float 32, though it's got a half vector option that is a float 16. Now, float 16 still has got about 8 to 10% bits of precision, and MariaDB's got a little bit more, so we're getting a good result by moving away from the floats. Quadrant use like a 32-bit int, but they've also got like an 8-bit scalar, and I'm not too familiar about their implementation, but it'll, you'll see the results of that on the benchmark. So we've got a graph of like the three of these on the bench. MariaDB, PG Vector and half vec, PG Vector at full vec, and the quadrant implementations there. So we've got the scale on the vertical axis is like queries per second. Obviously, the more queries per second, the better. The less resources it's actually using. At the bottom, we've got the recall from a perfect match over here to a less perfect match over here at like 0.7%. Everything I've heard is like anything less than 95%, don't really worry about, so probably ignore this half of the graph. But, you know, it shows the trends. The points here are the optimum EF and the M value for various points, and I'll go through a couple of results of that now. So if we look at like a perfect recall as well, what happens is what MariaDB gets down to a 18.3 queries per second, and we'll look at like some of the search parameters for that. We've got like an M value of 32 and an EF search of 200. If you look at like PG Vector is what they took to actually get the same thing, it was an M value of 64 and an EF search of 400. And this is, I guess, showing that across implementations, different values are needed to get the same results. So, sure, we're actually quite admittedly slower on than PG Vector to get that 100% mark. However, I guess the hierarchical navigable small worlds problem is about getting an approximate result quickly. So this isn't actually the case we optimized for. The case we optimized for is closer to this one. It's like, give me 99% results and make them quick. For this, we got an M value of 24 and an EF search value of 10. And if we look what it was before, the EF search was 200 and M value was like 32. So we've dropped it down significantly by just that precision going down. Mark measured the PG Vector results on the PG half vector, and they're half to 43% as per terms of queries per second compared to what MariaDB does. Quadrant did a little bit better, 66 to 98, 89, sometimes dyslexic, percent to get of the queries per second. I'm not going to go through too many of these. If we go down to 98%, a bit more, our M value from MariaDB before was 24, and now it's down to 16, but we've had like a 50% increase in the queries per second by, you know, just allowing that little 1% margin there. As we see, the PG Vector is around 40% of that, and Quadrant's dropped down a bit. Last one, I promise on the thing, if we drop the M value from 16 down to 10, we get a recall above 95%. And the queries per second went up again by, what was it? 1,200 to 1,600 queries per second. Oops, on that. So, yep, that's all I'm going to look at tables. So last I'm going to cover where it's actually supported. I showed the Llama index before. It's in that, it's in OpenAI, it's in the Hibernate. There was a chain discussion, however, it ended up that, we'll do our own module, and that's been published now. LangChain 4J is out in the 1.0.0 beta 1, and there is a pull request in the LangChain JavaScript as to what an implementation there. So, where to from now? Well, in some ways that actually depends a lot on where the users actually want to take us. There are different distance algorithms, there is Manhattan search and that kind of thing. If someone's got a good use case around those, there are tickets in MariaDB's thing to describe that, and we'll implement whichever's got the best business case around it. As mentioned, this is like hierarchical navigable small worlds. So there are other implementations like Ivy Flat. There's like DiskANN as that. So Ivy Flat is a faster algorithm with less precision. DiskANN is one that actually gets us beyond an in-memory database to something that tolerates a few things that won't fit in memory at the same time. So there's those kind of trade-offs in place, and those are both on the possibilities of things that we can implement. That's pretty much all I had. So is there any questions?
Let's thank the speaker. We have ample time for questions.
Okay, so all perfectly understandable. Okay, questions, Yeah.
So in terms of sort of memory requirements, is what you showed for the benchmark a sort of typical what you would expect, or what's the minimum it can go down to in terms of memory?
Terms of like memory.
RAM, yeah.
Yeah, it very much depends on which model is happening and how many elements in that vector of that model. So if you could have these are, I think they were like 1536 OpenAI kind of length vectors. If you went for a model that sort of generated 10, 100 things, that's, I guess, 10 times less on that. You've got a tricky question for me, don't you, Alkin?
Tricky question. Okay, you can have this one.
Okay.
So, okay, the follow-up on the memory question.
Yeah.
So this is, you create the index and it's in memory. Do you keep that, a copy of that in the disk, external
Yes.
disk?
Yeah, it's all persistent, so it's got our usual storage engines underneath. It's supported under InnoDB and ARIA and MyISOM underneath. They're actually worked out to be kind of hidden tables underneath, and I think if you're familiar with the algorithm, it's a bunch of graph-related things that are stored to implement the hierarchical navigable small worlds though. So it's those hidden kind of tables in the same way.
That answers my question. Thank you very much.
Excellent.
I have more questions, but let others ask. We have time? The other question I have is when the benchmarking is done, I know it's Mark did it, but do you have some sort of a idea of memory consumption during the benchmark versus...
During the benchmark? I don't think Mark actually published that.
He didn't.
No,
actually. Maybe you had some insights into it.
No, sorry, I don't have any more info on that.
Okay. So, all right, that's enough. Thank you very much.
Thanks a lot. Any further questions, comments? Wish list items?
Yep. If not, my LinkedIn profile is actually up on the page, and you feel free to message me there or Daniel@mariadb.org. But most interested actually, where to go next. Should we be doing an IB flat? Should we be doing, Manhattan distance function? Should be anything else? Oh, the other thing that was coming if you do a vector search and say you want to apply a where criteria of like where region equals X, we've actually implemented so that and what typically happens, you want an order by limit. MariaDB works in the way you expect for SQL. So if you set a limit of like 10 or 100 results coming out, it will give you 10 or 100 results, even if you apply where criteria to that, and that's pushed down into the engine. It's something we're going to work on making a little bit faster too, but at the moment it performs pretty much the same as without a where clause, but filters it appropriately.
Okay, then let's thank the speaker again.
Thank you.
We have about 8 minutes time. Feel free to, 10 minutes even. We start sharp 2:30 with the next talk. Yeah, in the meantime, enjoy. So let me introduce the next speakers. Two of my former colleagues, so I'm very happy to see them. It was 3 years ago that I brought Mercury to sponsor FOSSASIA, so they are silver sponsors, I think, so I'm very grateful for them. And I'm also very happy to see that every year more and more Mercarians, people from Mercury, are joining here also with talks, so I'm very happy to see you two here. I think you were last year also here, very great. So Mercury, they will speak about Mercury and what they're doing is about personalizing search. Please go ahead.
Yeah, thank you for the introduction. And good afternoon, everyone. Thank you for joining our session. And the topic today is the journey of personalized search in Mercari. So before we jump into the topic, let me briefly introduce our company. Mercari is Japan's largest C2C online marketplace, so we support users to list items they don't want or use anymore, and users sold the money to buy new items they want. So the company's value is to circulate all forms of value to unleash the potential in all people. And our search systems are powered by many open source tools. We use dbt for data transformation, Elasticsearch for item retrieval, and TensorFlow ranking to support machine learning models. We also use weights and bias for experiment tracking, and we use Streamlit to build our evaluation UI. So these open source tools has helped us largely increase the iteration of our experiment ranking experiment. So let's jump into our today's topic, the personalized search in e-commerce. The aim is to shift the millions of listings to find a better few that match users' intent and tastes. So let's see an example. We got a user query of Nike shoes, and ideally, we have a user profile, which indicates this user has purchased the size in UK 5. His favorite color is white. He has purchased Air Jordan. His common purchase price range is around 10K JPY. He also prefers new items rather than used ones. So the retrieval system just initially returned a large amount of items, which resulting in spending many time to browsing. And the ranking system, with knowing this user's preferences, can rank items that might meet users' interests higher, so that it will save user time to find the item he probably buy. However, this process is ideal. The difficulty is how we can learn the user's preferences and how we make items ranked by users' preferences. So to reach this goal, there are several challenges we need to face. The first challenge is that currently on Mercari, the SERP ranking is still subjective. We rank items between the item attributes and the relations between queries, so they are not ranked by users' preferences yet. And the second challenge is some queries can be ambiguous, which resulting in we don't know the user's intentions. For example, the query of one piece. In Japan, it can be mean one piece dress, and it can also be mean the name of the anime. So we don't know which items of category we should recommend to users. And so let's just think a moment. What kind of value will you value most when you create a ranking system to provide user with a perfect search result? So in Mercari, we will value different variations. We will value the item attributes. So for example, when users search for some fashion queries like dress, the result will be many different styles to choose from. From the result, we can see items, the dress in different colors, dress in different lengths, and dress in different materials. So it's vital for us to know what colors and textiles the user prefers so that we can prioritize these items. Yeah, and also we need to know users' preferences on the categories. Some queries like Louis Vuitton, Chanel, they are composed just by the brand names, so it will return a wide variety of item categories. From the result, you can see items from fashion, from jewelry, from the cosmetics. So if this user just want to buy perfume, the other categories are probably irrelevant to this user. So understanding user preferences on category will also help us to do the personalization. And of course, the variation of price. So for some users, they already have a very specific intention. They know what to buy. For example, like this user wants to buy macaroni and cheese items. Although the search result has much less variety in the type of item, but the difference in the quantity and quality will result in different price range. So some users may prefer paying less, while others might prefer paying more for a larger set. So price is also vital in the personalized search. And the last one is the variation in user needs. So in the process of search, the user's intention is always uncertain. Users have, so for example, when users want to shop for some fashion items, they may spend more time in browsing different styles they like. But for users have a specific intention already, they might just want to quickly find a good item with a good price. So to overcome these kind of difficulties, in Mercari, we are more focused on using users' implicit feedbacks, such as likes, views, and purchases, to generate user preferences. In the following session, we will cover these 4 personalized features. The first one is device type. We use this feature to understand users' behaviors on different platforms. The second one, use views and likes to understand the user needs. And the third one, last view items, we use it to understand users' preferences on different item attributes. And the last one, user category preferences, of course, it's used to understand user preferences on categories. And this is how users interacted with our items. They can do click, like, leave comments, and proceed to purchase. So these are all the signals we use to generate users' implicit feedbacks. So now I will hand over to my colleague Miao, who will give us more technical details on the how those personalized features are generated and share the insights from our experiment.
Yeah, thanks, Liro. My name is Miao. I'm also working in Search ML team. So next, I'm going to share some detail about the experiments we have done. So first one, if we think about the user attribute, the first attribute is device type. So we assume that user from different device may have different behavior and user preference. So here we simply add the device tab as a new feature to our search ranking model to differentiate users from iOS, Android, and web. So from the experiment result, we observed that the ranking result is actually different from different device type. And we also observed that iOS user could prefer higher price and Android user could score more on the search result. So that's some interesting finding. And we also observed that the positive business metric from all the platform. Yeah. And next, we want to integrate more the user view and like behavior. So imagine you search something and you see some familiar item from the search result, that's something that you may viewed or liked before. So in that case, you may have higher chance to purchase that items. So from this assumption, we introduce 3 new features for each item to represent if the item is recently viewed or frequently viewed by the current user. and if the item is already liked by the current user or not. And from the experiment result, we found that the model actually learned to prioritize the user viewed and liked item. However, the business metric showed negative from the A/B test. That's another interesting finding from this experiment, because we increased the exposure for the familiar items for the user. However, it can also reduce the freshness of the search results. So user using search may want to explore more new item rather than see some previous seen one. So that's also inspired our following experiment, that is use the similar viewed item. So we assume that the last viewed item from the user could represent the user interest the most, and use the last viewed item to represent user interest. We can just calculate the similarity between each item with the last viewed item. So here we calculate the lexical similarity, which is just the J-card similarity of two item name to calculate the exact keyword match. And another thing we tried is to use the cosine similarity of text embedding of the item name to try to capture the semantic distance between two words. So from the experiment result in offline, since we haven't done the A/B testing online, we found that combining the lexical and semantic similarity could improve the offline NDCG the most. And also we try to add some more context information like the SERP diversity. We found that it could further improve the offline metric. So we assume that adding more context information could help the model to find out the appropriate level to apply the personalization. And finally, category could be an important information for personalization. So we assume that based on the user previous viewed category, we can better learn what's the user preference. So here we first calculate the total view count for each user, which is how many items the user is viewed in last one day. That could represent the user activity. And next we calculate the category view count, which is the item the user viewed for each category within one day. That could represent the user absolute interest on this category. And next we calculate the category view ratio, which is category view count over total view count. That could represent relative interest. And on our platform, we have different category level to represent the different granularity. So yeah, we applied all these features on different category level as well. So from the experiment, we found that introducing more granularity for category level could improve the offline metric the most. And also combining both view count and view ratio could improve the metrics more. That could support our assumption that the model is better learning the both relative and absolute preference from user. Yeah, so that's basically the 4 experiments we have done in the few months, and device type, category preference, similar viewed item, and viewed and liked item. So we have some contextual feature that could represent user attribute, and document feature could help the model to capture the preference on each items. Yeah. And we are still at the very beginning of personalized search. So for the future direction, first we want to implement the real-time personalization based on the user behavior real-time on each search result. And also we want to introduce more attributes like size, color, price to better represent user preference. And last, we want to build a user embedding based on our item text embedding with the user click history. Yeah, and thanks my team, Search ML and ML Ops team, to work together on this project. And thanks everyone for listening. If you have any question, you can come to our booth, Milkali. Thanks.
Thanks, the speaker. We have a few minutes of questions. Please wait until I pass you the microphone, because otherwise you don't hear.
Hello. I was wondering if you have considered or are using any kind of collaborative filtering where you try and connect what the things that I like or purchase or view to other people like me and then use that for recommendations. It seems like it's a standard thing, so I was curious.
Yeah, that's a good question. So basically, that's like similar with our direction to build a user embedding. So when we build the user embedding, we will not recognize the user ID for each individual. So, and our ranking model is basically a deep neural network, and we expect everything is learned. The like similar users' behavior can be learned using user embedding and the deep neural network. Yeah.
Further questions, comments?
From your model, it seems the data majorly come from the user behavior. Is there the parameter from the platform or product itself that might contribute to this? For example, seasonal or popularities in products, or is there any parameter that might help?
Yes. Yeah, actually, we have more other feature not related to each user, but like CTR or the time the user is exploring. So we are more categorize those features as non-personalization feature because it's like, yeah. So yeah.
Hi, thank you. I have a question because in Debian we are also seeking how to recommend users what package to use. Do you think we could use your technique to say user has used package X, Y, and so he might like to use package Z? Can we also do something like this?
Sorry, can you elaborate more about it?
Well, the thing is we have 60,000 items, Debian packages, and users can't have a good overview what might be useful for their own purpose. So if we had some data that some users usually are using some of these packages and they tend to use certain other packages, then we can give maybe some recommendation what other users could use. Was it clear enough? Or we go back to your booth and talk about this?
Yeah, sure. That would be good.
Yeah. Let me answer this. So that's hard because what they mentioned is there is interaction. This is what we call the relevance, is like, command, even purchase. So that are signals that going from the user to the system that are used to partition or measure. And in Debian, you don't have, like, people don't vote for packages, or we could, yeah. Anyway, further questions? Yeah, let's thank the speaker again.
Thank you.
I have to say I'm very happy because 2 years ago, Theo, who is also sitting here for Mercury, and me, we presented the first re-ranker that was not personalized. We were far away from thinking about ever personalizing this. So it's great that the current search team is now working on a much better version of the re-ranker we have introduced back then. So thanks a lot for your work and for your great presentation. Let me introduce the next speaker, and talking about designing data toolkits. Please welcome the speaker and
Lovely. So those who have been last evening with the same session, you understand what we are talking about. We are talking about design. Those who are joining for the first time, welcome. Welcome for your time and listening. So today, apart from all the sessions that we are having, we are talking a lot about technology. We are talking a lot about how to use them, implementing them. This session is different. Okay. Is it better? Okay, thank you. So this session is more about how do you think using technology? How do you think building a data pipeline, and how do you construct the end-to-end understanding of that? The session is for everyone, irrespective of your technical expertise, and we'll be digging a little deeper on what we can do based on the organizational level to your individual needs. I'm Santika. I'm a founder of Data Journey Headquarters, where we build personalized data toolkits for small and medium-sized enterprises and non-technical founders. The more about you can, if you have the slides, you can click and understand what the organization does. So today's agenda, pretty much very intuitive. We will understand what are the ingredients that one should think and keep in mind while designing such systems. The second, of course, design itself. We are going to talk about design. Open source as a medium. We are talking about not at its core, but how open source facilitates designing and building these toolkits. A short demo of Data Journey if the screen sharing, everything goes well, but we have 15 minutes, so I might skip that. And finally, we'll stitch all these together in the form of takeaways. Wow, this video is working. So this is a simple interpretation, like when you are cooking a dish, you measure how much of these raw ingredients should go into your dish. You don't take a ton of potatoes and just smush it in there. A ton of garlic, just push it in there. What I mean by this interpretation is we have to quantify and qualitatively understand what are our needs, what are our goals, and how these come together in certain quantities so that we can make a delicious dish at the end of the day, which is cooked right to the perfect temperature, is presentable at the end, and it's usable, it's accessible to your users and your audience. It doesn't matter how beautiful your tool is, how amazing the back end is, how complicated the stuff you're building. If it's not usable by your users, nothing makes sense. May as well scrape it. So what's the problem that we have it here? And each year, each month, honestly, this list keeps on growing. What to use, when to use, how to use, why to use. Do we ask these questions often? Maybe not. How do we come to a conclusion that what tools needs to be used or what is giving the finest outcome out there? Most of the time, it's the experts on the team, or if you have something already pre-built as a pipeline in your organization, you just go and roll with it. But never thinking right from the understanding, like, do I need an entire Databricks system in my organization, or I can just get away with a small query engine? What are those decision parameters that involves taking and making those tiny tweaks in your pipelines? Okay, one slide back. So the solution is design first thinking. As much as this sounds boring, like why the hell she's talking about design, it's the fundamental core. It's like talking about concepts, algorithms, before we talked about building programs. The same is for today. To understand tools and what not to use and what to use at the end of the day, we have to play the elimination game, and hence, design first thinking is a step forward towards that. What is design? Everything starts with curating a mental model. What is a mental model? Is asking those questions to your C-suites, to your team members, to understanding those hard questions which nobody wants to ask. Why exactly we need this? Because it's in our budget. That's a fairly good answer. But why cannot we use instead of this, which is giving us better results, better efficiency? The team just understands it perfectly how to use that. The next is left shift thinking. Left shift thinking is there for centuries is an exaggeration, but at least a couple of decades. What it means is instead of implementation, we design, we think first. And as we design and as we think, the solution improves in the initial stages itself, so that we don't have to worry for the final outcome and not having to tweak and incorporate lots of resources in that. Finally, goals to technology. We'll dig a little more about what these means. Needs to implementation framework. Again, we are talking on the organizational level and not on the technological level. How do we understand what are the needs, what are the goals? And I would love that if we are interactive in this particular slide, what do you understand by a need? And please feel free to just brace up and answer this one. And it doesn't have to be a perfect answer or anything. I just want to understand what is your mental model of a need looks like when you're developing a project or we're developing a product or you're inputting your understanding to the team. Anyone? Please go ahead. Lovely. That's an interpretation at the level of action input, what a need might feel like. A need is unbounded, one word. When we go to the goal, it's bounded. What is bounded and unbounded? Bounded comes with boundaries with respect to what's your budget. It's a bounded entity. What is your resource capacity of your team? It's a bounded entity. What is the need? I want the best product out there in the market. I don't know how to do it, where to do it. I don't care, but that's my need. The goals are more refined and structured in that manner. Finally, we understand the gaps. Though they are interesting goals, but how about the gaps? Now your resource team is crunched. You have only 2 developers to reach to that goal. And those gaps also come back to the goals, and the goals and the gaps refine itself until we reach a consensus that this is what we can do. After all the 3 parameters working together, we finally reach to the step of resource and tool allocation. We don't talk about the tooling until we have our goals sorted, until we understand what our major gaps look like. After that, we do documentation, implementation, testing and learning. Business values are more on the understanding, like I want 15% increase in my revenue this quarter. That's my business value, and this feeds to the goal again. So business value and goals are connected with the gaps in there, and this model gives you an overview, be it you're an individual developer, be you're running your own business, be it that you're starting up as a side project. Understanding the mental model of how the decision matrix work will make you a more efficient developer, will make you a more efficient decision maker. And hence, it is important to think outside of the system and think more on the design philosophy than on the tooling philosophy. These are the buzzwords. After we understand what the design feels like, this becomes easier to look into. This becomes more understandable. Why scalability? Why maintainability? Why is abstraction important? Is my user a technical user, non-technical user? How should my abstraction look like? Will a CLI just do the job, or do I have to do something more? These kind of questions only arise when we think about design, when we put ourselves in the shoes of the users, and empathy is the key word to understand that. We talked a little bit about left shift thinking, but then there is interesting, which is much more efficient, is incremental left shift design. So left shift design says that do all the research, all the pre-work right in the beginning, and then start developing. What incremental left shift design tells you is to do a part of it. Like 20% of the 100 part of the research is done in the first iteration. Then you think about implementation. Don't do the implementation. Think about the implementation, how the testing looks like, how the features look like. And in the next iteration, you are left with 80% of the research. Now again, pick 30% from that 80%. So it's part incremental left shift thinking. And once you implement that, not only you will have something to show to your CXOs or your business suites, but also produce results that are more efficient. Left shift design failed in many cases because of the sprint analysis, because of the time constraint. And now when you have something as incremental left shift design, you have quantitative numbers to showcase to your respective stakeholders, and that gives you time and accuracy to build something design first. Definitely I had to add something with respect to AI, because how my talk would get accepted if I don't add something AI. So AI is important. The AI has gone deep into our day-to-day lives. And how do we design in the age of AI? What should we keep in mind? Should we shove the LLMs inside and think about doing a prompt analysis, or we think more or deeper? These are the questions to be asked. And not every day is an exaggeration, but pretty much all day, I look at this guide which tells you what are the design principles and methods in the age of AI, in the age of 21st century. It talks about, these are the two of my favorites, is I'll go from bottom to up, is design enhances human ability without replacing the humans themselves. Let's take 2 seconds to dig deeper. All we are thinking is how can we replace ourselves with respect to AI? How can I cut down my resources? How can I hire less? All these things is what we are thinking, and that's exactly replacing the human. Your systems are not incorporating the real crux of it is built for the people, by the people, and we have to understand that. The second is good design brings in long-term relationship without creating an emotional dependency. Quick example here. I love my Spotify liked list. Anything I come across, I just put a like and it goes to a nice list. One fine day, if I wake up and see that list is gone, I'll cry. I'll cry my heart out because that's one feature that I really, really want to have every single day and look at it and see what my list looks like. So there I created an emotional dependency for myself, though it's a long-term relationship. A good design, if there are changes to that feature, should eliminate the possibility of psychological, I think the word is psychological mismatch, or design philosophy should remain the same without adding extra layers to the top. So make sure you enable your users to now navigate with or without that feature. If there's a strong dependencies on that feature, the design should be in such a way that it could increase, it could decrease, it could stretch, and all these things should be thought about before eliminating that feature out itself. A good tech and design is discrete. This is the fundamental when I came up, is how AI and the existing core principles should go hand in hand and together. Instead of AI being the core, let's think it as an abstraction, a layer on top of your existing systems and sources. And what it does that, it increases your probability and chances to get into production. First thing, get the boundaries sorted. Now you have reproducible results without having to compromise on the quality, because still LLM is a black box. The outcomes that we generate are very much dependent on what it has been fed. If the food given to the LLMs are not great, whatever you get out of that LLM is not going to be great either. So not all LLMs are good for all purposes. Like I was experimenting with DeepSeek. It was amazing with translation and something which required responsive and attributes, while Claude is very fancy with all coding stuff, especially JavaScript, which I don't understand much. But it's fun. It's fun to play around with these technologies and see what works best, and it can be only done when it's at the abstraction level, because it gives you room to play around, to experiment. Once it goes into the core, your possibilities of exploration nullifies. So think LLM as an abstraction and not as a core principle. All this comes together, what I've been talking about, design first thinking, open source and stuff. I developed this framework. It could be accessible on GitHub. Feel free to check it out. Also, love to have new contributors onboarded onto the platform. This has an interesting design philosophy embedded in them, and what it gives you an opportunity to explore is how to think tools. How all this design thinking could be stitched together in one single open source project. And today probably it has about 9,000 to 10,000 clones already, and I work with a lot of organizations who are actively trying to understand how to do design first open source data solutions, and not just data solutions. And there is a stark difference when you start thinking about data. Take a look, feel free to shoot any questions, create an issue, let me know how you feel about it, and yeah, let's build. Now I talked about abstraction. Not all of us could interact with Data Journey because it's more on the technical side. So this Lean Launch Mate is a byproduct of Data Journey, which is available at beta right now for non-technical users and founders who want to do design first thinking but just don't know where to start, where to begin. And if you like to get on the beta list, feel free to reach out, give me a message, and I'll give you a solution, like a credential that you can log in, experiment, and seek feedback also in the process. Well, thank you. That's my email address. Shoot me questions or queries or anything that you have on your mind. Thank you, everyone.
Yeah, first let us thank the speaker. Yeah, as mentioned, we have ample time, 7 minutes for questions.
As usual, either you understood everything or nothing. And it's fair if there are things that you're still processing and would like to come up with more questions at the end of the day, it takes time. That's completely fine. And could reach out. I will be around here, happy to take questions. Or this session was all about like actively start to think design. And if I could like impart a percentage of it today in all of your minds, my job is done.
Last chance.
Last chance.
For questions now. Well, of course, later we have the speaker is around here for, I'm sure, for the next 2 days. Well then, thanks again. We have 6 minutes till the next talk starts at 3:15. Or 5 minutes. Okay, sorry for letting you wait. We had a bit of missing documents. So please, Sadapon, open source AI agent. We are a bit late with your talk, so please start straight ahead.
Hi everyone, sorry to keep you waiting. A bit about my company. We are Guardian AI. We provide RAG and AI agent and AI workflow automation for customer. And here's our work, a bit of award we have got, and some of the position I support the community. First, what is AI agent? Sorry, this is supposed to be a video, but I think every one of you who has been on the internet this for the last couple of days have seen this photo. It's a video of AI that help you manage like hundreds of social media accounts from just one screen. It helps you upload, take action, comment, and everything without API. It work with all the social media accounts through this screen. It's not through API, it's from the screen. You can see from that. And secondly, OpenAI just launched a new tools, which is the AI Agent SDK, and also new set of API that fully support the AI agent development. And from the investment perspective, you can see that the funding flow a lot into AI agent development as well, which leads us to the belief that this year is the 2025 is the year of AI agent. But what is AI agent? I'd like to start from the problem of AI assistant today. First, like ChatGPT today, it's lack of autonomous. It did a command from us to take action. It can do some reasoning, but cannot do multi-step complex reasoning. It can't collaborate with each other. It's still sequential processing. If you need to chain multiple AI together, you need to work one by one. And so here's the AI agent come in picture. Its key features are it can work autonomously, or it can think by itself, and instead of just provide you the result in text or in the image, it can help taking action from that result too. In comparison, from the AI assistants today, like ChatGPT and AI agent can work autonomously, work independently, and it can do planning, reasoning, and can do decision making as well. It can learn from the result. The output, instead of just text or vocal or voice or image, the output from AI agent usually the action and decision. Autonomous, if AI agent has very high autonomous, it can think, it can plan by itself, it can interact with the environment, it can interact even with the agent itself, and also it can perform the complex action. And in use case wise, there are many promising use cases from AI agent. One is what I showed, it help you manage social media account. It help you plan the trip. It can help you do the whole e-commerce operation analysis. And one of the good example if deep research. Deep research is a good example of AI agent because from just one single command, it takes multiple agent, multiple AI to help you research and do the analysis and do the re-research again until it gets the great result. But problem with AI agent that is not open source. What are the problem with that? First, you can see that AI agent usually related to autonomous decision making, and it's usually complex. How do we know how do they think? How do we understand how it's thinking? With the non-open source, we have no way to understand that. There may be some research paper to to try to understand how AI agent work through the interpretability of the model, but it's not as good as the open source model that we can test, we can see how it works in action. Secondly, adaptability and flexibility. AI agent needs a flexibility to work. With the non-open source, we have to wait for the provider to provide that for us. But with the open source option, we can do whatever we want. With that, we can just add the ability that our company, our one customer needs. Third one, safety and reliability. Because in the future, today and in the future, AI agent will take action for us. So it will be a lot safer to understand that how much we can rely on that, how that model make decision. And if you want to build AI agent using purely open source, is it possible? My answer is yes. I will take the basic AI agent architecture that we have one central entity, do the planning and reasoning. We have the tools that connect to the outer world, for example, API, search the web, connect to ERP. And on the other side, we have a memory that do the knowledge retrieval. It can be from sensory, which is the IoT, the sensor outside. It can be short-term, which is the system prompt. And it can be from the long-term memory, or what we usually call the rack. And working together, it generates the result, or it use the result to interact with another agent. That's the basic of AI agent architecture. Let's go to one by one. The reasoning and planning model. Today we have a DeepSeek R1 and Qwen QWQ, which is a very good open source. And just yesterday we have Gemma, which is one small open source model that is very good at the reasoning as well. So on the reasoning side, which is this at the center of this, on the reasoning side, yes, we have a open source model that support that. On the RAG side, first one we have to think about the embedding model. Luckily, we have a benchmark on the embedding model. You can see at the Hugging Face. This one, I filter only the open source one. And it usually goes with something like this, which is pretty good. But in the embedding, my advice is you have to try. Because sometimes in the context of your work, you have to deal with some domain-specific work or some domain-specific knowledge. Some embedding models are good at something, but not everything. And so here, this is from my research and my experience. If you're facing with some domain-specific, maybe you need to work with some non-open source. But for the good result, regardless of the open source and non-open source, for if you deal with publication, PubMed and BioLot you always provide the good embedding result. And for law and finance, CodeBird, Graph CodeBird is very good. And if you are dealing with specific languages, embedding model impact a lot on the outcome and on the result, how good your RAG application will work. If you work with Japanese, there's some embedding model that are very good at Japanese. Chinese model is very good in Thai language. Too bad, there's no Thai native embedding model that were very good. We usually rely on BAI, which is Beijing AI, or Qwen is also pretty good on Thai embedding as well. And for the VectorDB, pretty much like in the previous presentation, that MariaDB also provide the vector search capability. But what the AI developer today usually use, we always go for Chroma, Wave8, Quadrant, and Postgres with the PG vector extension. Each tool are pretty much similar, no much different. But what makes our life easier is the integration. Some tools, some development framework like LangChain, Llama Index, or some API for already integrate into that tools, which make our integration easier. And on the scalability side, some can be grown to cluster, some can be scaled like to billions objects. Some rely on the PostgreSQL capabilities. And on the development framework, we are very lucky that most of the framework are open source. The most popular one right now is LangGraph, which is one of the family of LangChain. And CrewAI, this is very good as well. It provides a lot of tools in case you need to build a complex multi-agent ecosystem. Microsoft AutoGen, this one is pretty good as well. It works very well in the multi-agent with one single orchestration. If you are dealing with an environment that we have one agent orchestration and multiple sub-agents that talk to that orchestrator, Microsoft AutoGen is the go-to tools for this. But you have to be careful because it updates quite frequent when you work with that. Check with the version of the document as well. And the last one that just launched a few days back is the AI agent from AI agent SDK from OpenAI, which provide a lot of interesting features. For example, it built in the guardrail. Guardrail is how you prevent user to ask something you don't want, or prevent the AI to answer something you don't want. For example, you build an AI agent for finance. You don't want your bot answer something that's not related to your application. And also it provides the exit point as well. It provides a stopping point where you tell AI agent that it needs to stop. Because in other AI agent, when you let agent think for itself what to do, sometimes it works indefinitely, think and work indefinitely. The OpenAI agent framework provide the exit point. This is very interesting point. And also last one, the open source is not just about the code. It's all about how we think about the technology as well. Using AI agent with open source, again, it's not about the code. It also helps us in collaboration and knowledge sharing, because I personally see open source as a knowledge sharing and where the people around the globe collaborate to build something together. And economically inclusive. If you realize the AI agent in the closed source, sometimes expensive. Sometimes expensive. Sometimes it's blocked by some countries to use. Depends on the regulation or the government. So the open source also help the inclusivity as well, and also on the accessibility side. Also in the decentralization of power, instead of having a few big corporate to research and harvest our resource of the world on this, we can together help make the AI agent that works as good as that what big corporate do. And that's what I would like to share about AI agent from my experience. If you want to discuss more about this, do not hesitate to contact me via this. Thank you.
Yeah, let's thank the speaker. We have time for a very short question. Anyone?
Hi, Mishari Mukbil. So how good is the support for Thai language now? Because traditionally, I mean, I've noticed that there are problems. It's either not natural, or occasionally we get artifacts in Chinese.
Okay, good question. Okay, when we talk about supporting in Thai language, I guess you mean the language model that support Thai. We have a couple of Thai language focused foundation model. I think we have 4 to 5 language, but most of them are the fine-tuned from the Chinese model, which is a Quen or Qianwen. So sometimes it's just possible to generate something that's not related and with Chinese influence. But I think we are getting better with this. We are going to have our Thai language focused reasoning model as well, going to launch, I think, this month.
So just small like a sales point. If you are interested in helping to improve the data set for teaching what's the Mozilla Common Voice, there is a booth for the Common Voice. So if you're a Thai speaker, thank you. Please come and join in and let's help make this better.
Yes, I would encourage everyone to support this initiative.
I no time, but I had the same question just for Japanese, because for the Japanese models, often strange characters pop up still. So I was interested, but time running out. Please thank the speaker again.
Thank you.
The next speaker here. You are the next speaker. You have sent your.
I uploaded it on the phone.
Okay, then.
You sent today or not? I sent back when there was a thing.
This is incredible. The hell is this talking? Cannot even select it. So, the open source AI agent? No?
Oh, okay. I will copy again.
Why now it is talks not here? So what is the finding? No, it's not this. It's not the Wi-Fi. It is just too stupid. Why is Google so stupid? Yeah, wonderful. Do you know it? Well, yeah, but this problem is how to get it here, right, on this computer. There's no way to go up again. I mean, why? No, this is the order. This is only the order of files, how they are displayed. we have to do it for now like this. I don't know.
Okay, where's the?
That is on this side.
Sorry.
You have to
All right.
just watch on the.
Got it.
Okay, please go ahead.
Yeah, let's thank the speaker. We have time for a short question.
You mentioned agentic AI chatbots and call centers. How would these systems be made sure to like prevent malpractice and like scam call centers? How would they not be taking advantage of this new technology to increase their seemed legitimacy?
For someone to access it, they should be able to have some control on it. So that's way you can somehow control these cyber frauds.
Okay, thanks a lot for attention. Time is running out. We have a short break, so please take yourself, help yourself with coffee and stuff. We start here at 4:10, 10 past 4 in this same bill. Please, the speakers of the second half, it would be great if you are here and come here and could check whether your files are here and everything works, because otherwise we have these delays again. Thanks, everyone.
Also, manchmal frage ich mich echt.
everyone. Can we get ready for the next session, please? So, thanks everyone for coming back or remaining here. Let us start straight ahead with our giant on automating workflows with LLM.
Can I start? Hello everyone. I hope you are good. And I start by saying I am sorry if I am not the most energetic today. I'm not the most well I am. I'm Saurav and I'm a senior developer community manager at Appify. And I manage the developer community of Appify. We have a huge community of developers building on our platform. Before starting my talks about automating the web workflow with LLMs, I want to introduce you to Appify because I am going to talk about Appify in further slides, how we made workflows using Appify. So it makes sense to talk about it. Appify is a web scraping and browser automation platform. Okay, now it's better. So we provide a cloud platform to all the developers where you can publish your web scrapers, your AI agents, or your automation tools. And we have an app store of more than 4,000 tools which you can use that we call actors. Actors because they run on a script like an actor in a Hollywood movie. We also have SDKs in JavaScript and Python to support development of actors on our platform. And we also have open source libraries from which you can create those actors. Open source libraries like Trolley, ProxyChain, and Fingerprint Suite if you want to check out. We started in 2016 as a web scraping platform where we have many where we were scraping data for many companies. And one of the main use cases since 2016 was to get data to feed AI models. And this has been one of the main use cases for our company since then. But with the rise of LLMs in 2022, an entirely new use case generated, and that was RAGs. Fetching up-to-date data to generate prompts for LLMs. That is RAG, which is amazing because you can have a entirely take off the shelf LLM. You can feed them the data, the right prompt, and ta-da! You have solved an entirely new use case that can be you can ask questions about your internal documentation, the blog post, or anything in a limited scope. So we have created many tools in our company for many of our clients and many of our actors. So I'll be discussing few of them as a case study in this talk, and I'll be telling you what problems we faced and how we solved them. So starting with intercom fins. Whenever you go to any website that have that small support pop up in the right bottom of the website that uses intercom to write a support query, the chatbot name is Fin. And whenever you ask them anything about that particular company, the chatbot try to generate an AI answer. And it mentions a source of truth always there, which you can see here, the source of truth. And that source of truth is always generated through Appify. So we scrape the data from their documentation, their blog post, and everywhere to feed that data to LLM and to generate an answer for your query. But in today's talk, we are going to ask ourselves, can we use LLMs to automate web workflows? So far, I have only talked about data, but it will be amazing if an AI agent can perform actions on our behalf, and we don't have to write code of it. We can just talk in a natural language, and they can do all of the work for us. And many of our customers, many of our users are very interested in it. And I will start with an example of Rocket Money. So Rocket Money is one of our customer, and they what they do is they unsubscribe streaming services on users' behalf. For example, we have many streaming services, Hotstar, Netflix, etc., and they don't want us to unsubscribe. They make it very difficult. So the company automate the whole process to unsubscribe from a user's accounts on Netflix or on Hotstar, on many streaming services. And currently, these workflows are written by programmers, which is a very manual thing to do, and very it sucks to write automations and do things, because there are downsides. There are many downsides. And so what was the motivation behind thinking of doing this AI agent for web workflows? So the first problem is the target website changes a lot. So Netflix don't want us to scrape their website or automate the whole process, so they change it every time. Every website do, every good website do, and it is a problem. So this is something that your team, your programmers have to do it again and again and again. Whenever there is some change, they have to sit on the code, write again, and this is not scalable at all. The second thing is non-programmers cannot do it. So you always need a programmer to fix these things, and this is also a problem. So this is not scalable. You have to manually write the code, and it is not friendly for the people who cannot program. So what if an AI agent can do all of these things for us? What AI agent can do, if an AI agent is doing this, they will, the agent will parse the whole HTML of the website, so we don't have to worry about the selectors change every time. Every time they will, the AI agent itself will check the selectors, so we don't have to worry about that. Scalability will improve, obviously, because of this, because we are talking in a natural language, not in code. So anybody who can do this, even non-programmers. So it will be amazing, right? So let's think how to build such an agent. So just a disclaimer, I will talk about the current research and everything a little bit, but I'm not the expert in it, and there is such hot research going on in this field, so I might be outdated or something, but I will try my best, whatever I have recollected from my team and we have done. But yeah, just a heads up. So there are three things: LLMs, VLMs, and multimodality. I know most of us know about LLMs. How many of us know about LLMs? Okay, like few of us or most of us. LLMs are where we talk with the, like we generate prompts in a natural language. We don't use voice, we don't use image, we don't use anything else, just the natural language. And those are LLMs, then large language models. And then we have VLMs. VLMs are not as common as LLMs. They are vision language models. So we give the models prompt with an image or a visual thing with the text. So these are vision language models. And then there is multimodality, which seems a very good fit for the use case that we were doing. Multimodality is when you are providing the model text, audio, image, video, everything. So for example, GPT-4o Omni, that model is also multimodality. And this seems the right fit for our use case. And you can see there's audio, text, image, videos, multimodal LLM, and output can be an image that depicts a rotary phone, which talks about a text or talks about a description of a video and the things. So what we should show or input to the model? This is the next question. And I will talk about the 4 things that we did in this particular use case. Yeah, this depends on every use case, but let's start with the first one, raw HTML. So it's always the best thing. So if you are trying to automate the workflow, for example, the Netflix one, so you'll give them the whole HTML structure of the website where the agent will go and they learn from the structure of the website. But we did one step ahead in this, and because HTML structure are very big, we removed the redundant structure, and we added a specific tag with each HTML element and attribute. and use and we whitelisted few of them which were relevant for us, and we used only those. So we are using limited HTML for more efficiency. And then we feed the accessibility tree about the accessibility related information of the HTML elements. You can think of it as a denoised version of any HTML structure. Then screenshot of the page. So because it makes sense. For example, I said website changes, and they can introduce any CAPTCHA at any time, any the cookie model at any time, and it's a problem. So if AI agent don't know the visual representation of the website at that time, it's a problem, because if there is a cookie model on the top that says accept, and we told the AI agent to just click on something else, and it don't know about that visual representation of the page, it will fail. So the visual representation is very important, and that works very nicely here. But we go a little bit advanced in this. We use set of marks, which is again a concept. You can read the research paper on Google. But in this, we mark every important button and important link of the visual representation with a specific mark that we used later on in the HTML structure too. So that the agent knows everything more specifically about the buttons and the links that are in the screenshot of the page and are important to us. After that, we talked about input until now, but what about output? So there can be two outputs of our use case. Either it can be a code, or it can be an action from a set of defined actions. So let's talk about the first one, and I know every one of you will relate that we also tried it with AutoGPT. When we ask the AI to create a code, it looks very good. It looks like another thing, like we have achieved everything in the AI field, but when we run it, it is horrible. And it never works very good. It is very random at times. You don't know what it will do. It will use some old depreciated library and create a code which is not working or doing something very random, and it is a problem. So I couldn't help myself, and I included this meme into that LLM generate plausibly looking code, but the code doesn't work. So that's a very big problem. You'll be asking yourself why the agent is doing this, and but there is nobody that can answer that question because it's just LLM. So we tried the second one, and in the second one was a predefined set of actions. So we limited AI to do some predefined set of actions so that it is not hallucinating that much and going beyond something. So we decided for this particular example, we defined two predefined actions. It was go to that URL of some particular page, or click on that element of some particular page. And here the AI will, there are parameters and there are actions. So AI will just choose any of the action in the written and decide the parameters that should be used with those actions. So it worked in our case very good, and the AI wasn't hallucinating that much in this. So we prefer this method. And then challenges that come while we were doing this. The first one was HTML size versus the LLM context length. So it was a problem. HTML structure are very, very big, and the context of the LLMs were small. So this was a problem, and I told you, like, we tried to reduce the HTML structure by tagging and everything, but this is a challenge. You can also reduce the HTML structure by opting for reading mode, but again, when you have to talk about the links in the HTML structure or the button, the reading mode doesn't help that much. So it's a challenge. The second challenge is stochastic nature of LLM versus testing. Again, the same thing. That inconsistency of LLMs. So you can ask LLMs the same question twice, and you'll get two different answers. And for the third time, you'll get a third new one, and that is a problem which we faced pretty much. So we cannot really rely on LLM on something. So we tried to limit the output of the LLM in the end. You can set the temperature to the 0, but it reduces the creativity in the end. So testing was quite difficult. You cannot really, like testing was difficult because of different outputs many times. And the last, web automation is difficult on its own. You can get any CAPTCHA in the end. You can get, even after clearing so many cookies model, you'll again get CAPTCHA. People are using crazy JavaScript, TypeScript framework like React, Meteor, and everything to make things more difficult. So yeah, you want to take a screenshot of the website, and yeah, there are 3 cookie models to accept, 1 CAPTCHA to clear, and JavaScript rendered websites to manage. And yeah, but so is life. So yeah, this is also was a big challenge for us. And yeah, the cookie model example, so we tried to solve it with the screenshot of the website. And the immature tooling, I say we used LangChain in JS in this, and we found out like the JS version code wasn't that good, but documentation was worse. So this is something that our team didn't like pretty much. But the best part of the presentation, a demo of our AI agent. I recorded it. I didn't know that we can do the live demo, but let's see it. You have seen many demos on Twitter about AI agents where any influencer will take 10 prompts and one will work, and they will show it to you and say, yeah, AGI is achieved. So this will be the same too. This is not going to be very different. But what we are going to do in this is filling and submitting a form. So we ask the agent to go to apify.com and go to, then we, in instruction, the start URL is Apify homepage, and then we ask them to go to store homepage, search for AI web agent, which is the project that we worked on, and click on the first result and take a screenshot. So maybe it will work here. So yeah, you can see now this is agent doing it. I didn't do it. So it went to the home page. Then it's trying to go to the store home page. Now we are on the store home page. It searched AI web agent and clicked on it, and now it is taking a screenshot. So this is all AI agent doing this thing and automating the workflow that we wanted to do. And for the next example, yeah, so we can also see the agent's log. So you can see first agent went to the target website, then click on the link of the Apify store. Then it started filling the form with the values that we gave it to we asked agent to do. And then it submitted the form, click on the link, and in the last log was to capture and save the screenshot. So this was the first example. The second example that I did was again, the start URL was Apify homepage, and we asked agent to go to pricing page, extract the information about all pricing, and save it to a data set. So we asked them to save the following properties: plan name, monthly price, and actor RAM. So for example, we have 5 pricings, and when we asked agent to, I didn't record this one because it will be redundant, but the extracted information was something like this. We got information in this JSON file where plan name is mentioned, actor RAM is mentioned, and monthly price is mentioned for each pricing on our page. So if you want to try the agent, you can just scan this. We have an actor on our store. You can try there. The agent is open source, so you can also go to the code. You can ask questions there if you want. And yeah, if our team will love to get your feedback on this if you have any feedback on this. So yeah. And if you want to connect, yeah, please do. And thank you so much.
Thanks for the interesting talk. We have a few minutes for questions. I register one.
Does it support some kind of human-in-the-loop interaction? Because some form might require additional fields that you are not aware once you query the agent. But agent can go there and see that there are some additional fields that you require to fill. So how does this happening?
I don't think we currently support any human interaction. You just have to enter the instruction starting and it will do this thing. But yeah.
But if it doesn't have these fields, initially it will just fail and say provide these fields.
Like I can show you if you visit the code, you'll see the inputs and outputs. It's very defined, so I don't think that will fail you. But you have to provide the proper instructions, otherwise it will fail. Yes.
Okay, I see. Thanks.
Maybe related question. So can it bypass captcha or fill captcha automatically somehow?
Using Epify, yes, you can. That's why it's on our platform. Our platform can bypass CAPTCHA too most of the times.
Any further questions?
So in this case, you're using the HTML. Have you considered using like images and using that with the LLM to see if that improves its ability to get through things?
Sorry, I think I mentioned we are using images too with it. I mentioned in the PPT we are using images, HTML, and images even with the set of marks. So we are using multi-models, not just LLM.
I have a request. I'm from Archive. We are one of the most scraped websites on the world. I would request you that you could please follow our policies. And this is not using the APIs, but the export server. It is clearly stated on our website. That would be greatly appreciated. I checked your API bot at the moment.
We will talk.
Any further questions? Okay, then let's thank the speaker again.
Thank you.
And we are starting at 4:40, so in 8 minutes. This is true, but we have a policy about scraping that requests that you use the export. Yeah, please. I will surely get in contact with me if you want details.
Yes, I will for sure.
Let us start with the next talk in this session. It's from Jun Io on open source behavioral analysis platforms. Please welcome the speaker and please start here.
Thank you for introduction. Hello everyone. I'm very happy to be here, and today I'd like to introduce the two research platforms for which can be used for conducting behavioral analysis, and they are provided by as open source tools. I am Jun Io from Professor of Chuo University, Tokyo, Japan. Okay, I'd like to skip this slide because we don't have enough time today. But my major is human-computer interaction, and recently we are focusing on the behavioral analysis by using research tools. We own research tools created by ourselves, and today I'd like to introduce two platforms. One is the create your own stories. COYA, create your own adventure. Do you know COYA too? Oh, yeah. So COYA stands for Create Your Own Adventure. It's a kind of RPG role-playing game, and we hired Twines to create our own research tools. There are many gaming platforms like this: Twine, Inco, and ChoiceScript, and Hungis. I'm sorry, I don't know the Inco. I don't know several tools, but because we hired only Twine, but Twine is very good, very fascinating tool to create COYA, and we hired Twine as a research platform to create our own questionnaires, questionnaires. In addition to that, we have the other online experimental platform like Gorilla and Pavlovia, which are very common tools, especially among the cyclists. But we are not cyclists. We are engineering. Our laboratory is engineering laboratory, so we don't use these online experiment tools. But as I mentioned previously, we selected Twine as providing research tools. And we choose Twine 2.8 and Snowman 2.0. Here is the prototype. This slide shows a prototype of our tools, like this. In this figure shows the relationship between several pages. Pages mean the screen provided to the participants of the research questions. From the start page, there are several options. In the start page, we put the questions which have the three options, and user can choose the option to proceed page A or page B or page C, and then the page is transferred to the second question and blah blah blah, just like a normal, just like a questionnaire tool, online survey tool, just like a Google form made by Google form or something like that. But our tool can collect the information of not only the selection but also timing. Timing means the usual such question tool cannot collect the timing information. Timing information means that, okay, the right one shows the who selected the option D or option E or option F, like this. This figure indicates that 4 participants chose the option D and 3 participants chose the option E, and the 7 participants chose the option F. But the color has the special meaning, which indicates the timing. Red one means the participant had more time to choose, and blue one is the easy question. That these colors show the timing to provide the timing where the participants choose their own answers. This is an overview of our system. We can create the whole questionnaire by using Twine platform, and we collected access data and also the information from the Twine tools by using Twee data, and then we merged these information to create these graphs, the result of graphs. This is the preparation part of the Twine. Our script is very simple script. In this script, provides the unique ID unique ID for the participants, and several scripts to collect the user's information. And the last page is very simple one. This is the very simple one. The last page can show the indicates the participant's ID in addition to the participant's ID, but also the these pages can show the results of the selection by participants and timing like this by Unix epoch. And the results are sent to our server, and this sent to servers, and we can collect the information by using this very simple PHP script like this. This is also an example by which was developed by our students for their thesis, and they. I'm sorry. This is written in Japanese because the students can students wrote their thesis by in Japanese, but this is the result of their experiment. The number of participants was more than 100 persons, and this is a kind of simulation of disaster, which try to figure out how the people behave if the people encounter very big, large disaster, like tsunami or something like that, earthquake. So the interesting result is here. This is the question where you are going to if the path is the evacuation path dividing. So someone choose the place people gathering. Someone chose the main street or blah, blah, blah. This is very interesting result. And second one is the GUIS. GUIS stands for the General and Universal Image Data Evaluation System. I'd like to talk about the overview of GUIS system. We are very interested in the evaluation of how people feel like the feel something when the people see the several images. For example, let me show the example here. Yeah. Okay. In this case, how do you feel like that? How do you feel when you see these images? This evaluation platform asks the participant to feel two axes of the evaluation, which is arousal and valence, plus or minus. So we can set up these type of experiment, and based on our first experiment, which provide movie posters. That experiment showed the movie posters and participants to collect the data, how the people feel when the movie posters. But after that, we developed the general purpose the research platform, not only movie posters, but also every images with two axes. And the platform provides informed consent first, because recently we are very severe. If we'd like to conduct the experiment by to someone participate in, we are very severe to have some experience. So we need to show the informed consent page first before experiment conducting, and then introduction will be shown here, and then evaluation is provided. So this is the information consent page and introduction page. We can use introduction page like this by using markdown format. And if this button participant to the experiment click this button, the evaluation page will come up like this, and we provide six images randomly chosen from the database, and then we ask the participant to choose the assessment of this using by these two sliders like this. And the final page is like this. This is the resulting page. Resulting page shows the differences between participants chose the result and the average score by the other participants. This provides some gamified information, which enable other more participation of the users. We expect the participant more and more to participate in this experiment to collect the data more and more. So we try to give some gamified information like this. Okay, of course, our system guides provided by open source software like this. You can access the GitHub repository. So if you're interested in this type of research, you can freely use our platform. Okay. Okay, let me conclude my talk. In this talk, I'd like to introduce two research platforms titled Part 1 and GAIS. Part 1 is Twine-based behavioral analysis platform, and GAIS is an image data evaluation system. Okay, thank you. That's it. Thank you for your attention. Any questions?
We have a bit of time for questions, like 4 minutes.
Could you give me some examples of the kinds of, some more examples of the kinds of stories created through Twine that you did research on?
It's up to you, but because the Twine and GAIS, both system is very flexible, and if you we have very little restriction of these platforms, so you can create freely. You can create your own story as you like. Of course, there is some restriction, but it's very short, small restriction.
Any further questions or comments? Well then, let's thank the speaker again. And maybe the next one can prepare. One more minute or 2 more minutes, right? Oh. It's disappeared. Okay, our next speaker is Koji Anoura, speaking again on as a vector impact on similarity extraction. Please welcome the speaker.
Hi. Okay, let's get started. And I talk about vector. Do you like vector? Oh, yes. Title is Vector Impact on Similarity Extraction, Movie Data Analysis. Okay, my name is Koji Anoura. I live in Fukuoka, Japan, south of Japan. And I love Neo4j graph database and Apache Hop. Do you know Apache Hop? No. The new Apache project here. Okay. And today, agenda is very simple. Three talk. One is view. Second is vector. Third is movies on vector. First, I like the picture. Okay, this is a human view of an apple. Okay, a middle, a vector view of an apple, and right, knowledge graph view of an apple. Are you familiar? Which is familiar? Middle one? Okay, knowledge graph view of apple. So apple is a kind of a fruit, and apple body shape round, and size 10 centimeter, and the color is red. It's easy to understand. Japanese. Oh, you're human. Okay, human friendly is here. It's very easy to understand. Middle is very difficult. Okay. The computer friendly is middle. Vector is computer friendly. Knowledge graph is so-so. It's not good for relational database. It's good for a graph database. Okay, vector. So this is a question. How similar are these two sentences? One is Pokemon. Do you like Pokemon? Okay, yeah. One is One Piece. Title is here, and plot is here. How similar? Please guess. 50% or 30%? It's not 100%. Okay? And numbers are easy to compare. Yes. So we can translate a text to a vector. Vector index is very familiar in these days. Postgres is vector is with PG vector. It works at adding a software. So MySQL is vector is work. MySQL 9.0. Neo4j is work with vector. And MongoDB is well work. What is vector? Vector has magnitude, length, and direction. Okay, you're very familiar with mathematics. So the 2D is here. It's easy to understand. 3D is easy to understand also. Example of a 3D array. Comic book, One Piece, Naruto, Attack of Titan, or something. So like this. So very simple vector. A vector is here. 3D array is here. Addition and artistic style. It's so easy. So this is a question. How many dimensions should be used for natural languages? So text is here, Pokemon. Okay? Please raise your hand. Okay? Dimensions, 2 dimensions. No? 3, 18. 256? No. Oh, okay. And 50, over 50, 50, 12? No, 512. Or more? Okay. This is a high dimensional vector. I used over 1,000. It's not 1,000 words, but we used 1,536. So we can translate text to vector for some some tools. So this is from OpenAI. And this model is 3 models. Okay? And this is a Python code. It's so easy. So this is a Gemini embedding model, 3 embedding models. I think it's last one is free. It's also easy. And sentence transforms SBART. Sentence transformers. Do you know the SBART? No? It's really free to use. Yeah, good. So I compared 2 tools. One is OpenAI, text embeddings, Ada 2, and the last one, SBART. So really small. So this is a movie, a title and plot. So, okay. Toy Story is here. Pokemon is here. I can write. Oh. A One Piece film is here. Do you like One Piece? Yeah? Okay. And if you like this movie, One Piece, so how would you search for next one to watch? Ask someone who knows a lot about movies. Or ask ChatGPT, ChatGPT 5 or 6 or 7. And looking for a recommendation online. And last one is vector search. I used cosine similarity. And OpenAI and SBART. Data movie data are like 9,000 movies, and I select 8 movies. This is a Shin Godzilla. Godzilla, do you know? Yeah. Oh, OpenAI versus SBART here. Shin Godzilla. Next recommendation is Godzilla. That is not the same. It's really interesting. Toy Story is here. I don't know 9. Do you know 9? But you like Toy Story, but recommendation, Child's Play. So very scared. Next, Star Trek is here, so different. This is OpenAI. This is for SBOT. Space Odyssey is here. So very different. Die Hard, so old one is here. One Piece are very different. So recommendation. So Steve Jobs, so-so on Steve Jobs. I don't know Jobs, but it's about Steve Jobs. Last one is Pokemon here. Pokemon, the first movie. Okay. I think it's a little bit good. Pokemon 3 or something. This is, I don't know, Pokemon Fry 2. Okay, two types of tools we compare, so very different. Okay. Yeah.
Okay, let's thank the speaker. Unfortunately, we have to postpone questions later on because we are a bit over time. Or do you have one very quick question? No. So then please, the next speaker, is he around? Well, if not, then Charonton Limsilo. Okay, good. Then we have time for questions. I hope he's coming. Yes, go ahead.
I was wondering, when you compare two different embedding models, how do you get a sense of which is better?
It's good. It's really free, so it's easy to use. Which better? I don't know.
I think that's a good question. If we could measure that easily, training and everything would be much easier, right? I mean, because it's subjective in many cases. Any further questions? Well, then not. Let's please thank the speaker again. Know what I should do now. I can dance in front of you, I think, but you will not be very happy with both of it. So let's see if the speaker is showing up. I can at least prepare the. Do you need anything else but the slides? Okay, well then, go ahead. Slightly late. Right, slightly late. Is this true? messed up the time. I'm so sorry. I cut you short. I was. I cut you short. I'm so sorry for that. It was the last slide, and then I thought it. Yeah, then we have. Anurag, you want to discuss a bit more about comparing?
Yep. I think I will start.
One question, is the last speaker also here? I cannot pronounce this. That fits in the first 2 minutes. So please welcome the speaker, Jean-Antoine Limselo, on small language models.
Right. So good afternoon, everyone, and also good afternoon to who streaming on online and also who come back to watch the video. So today I would like to present to you about small language model, which is would be a new frontier for developing the open source generative AI to sustainable goals. But first of all, I would like to introduce myself. My name is Jean-Antoine Limselo, or my nickname is Boat. I'm Microsoft Learn Student Ambassador and also data engineer intern at 7Peak Software. So if you would like to keep in touch with me or have to connect with me, you can scan QR code or follow the following social platform. All right. So the contents will be like, we'll run for 20 minutes, and also we can explain on the contents that I show you, even on the problems of using GPT is nowadays. And also we're gonna talk you about the comparison between small language model and small reasoning models. And I will show you how to use them in sustainable ways. And I will leave you a key takeaway. So the first problem is the generative pre-trained models, or even you can call it ChatGPT. We might wonder something that OpenAI is not really open, right, as a name, but and also OpenAI is is really 100% proprietary, so they use for profit making. But for open models, it's like freely available for modifications and redistributions, along with you can like publicly available and publicly release within Hugging Face. And also we have a problem when you're using OpenAI. You can see like we have a major outage, and also we have like since we have major outage, the problems because they would like use a highly computations in the server of OpenAI, and also when you operate the computation, it will come in with the higher cost of operations. And also we have a problem in January 28th in the past month. We can see like we have a problem with DeepSeek API too. So I will show another way to like develop or use among the organizations. So maybe could we try small language model or maybe like small reasoning model? But there's a key difference. For small language model, they have a benefit to use, even on cost, maybe on deployment flexibility, and also we have an ultra low latency and easy to customize in many platforms. And also is used within the specific resource and also select tasks to improve the performance by fine-tuning or using another techniques like RAG. Actually, if you try to compare the size of language model, you can see like large language model have a lot of parameters, but we can see the downsizing version, which is a small language model, is quite small and have a less cost. Some would be more specific, some would be in general, but it should be lower or equal to 8 billion parameters. But surprisingly, that I got from paper, it said that GPT-4 Omni is quite around 8 billion parameters. So when you compare between proprietary and open models, when you have a training the knowledge, you can see like ChatGPT have or GPT-4 have a good knowledge to give the knowledge to you, and also some of the models of open models give also a good quality of the knowledge. But I want to ask myself and many, like, how OpenAI distillates GPT-4 or GPT-4 Omni and remaining on a good results. So there's solutions called pruning and distillations from big models, which is from pre-trained data mix, and also we use the inference stack and become the logic data. Since they used the first pre-trained model and we become in 1 billion parameters and also with 3 billion parameters. But actually, if you have some synthetic data prompts, you can use to fine-tune it and become instruct versions of models. So I would like to give you some example lists. We can see like even on Llama 3.2 or maybe Gamma 3.4 billion parameters that being released for like a days ago, it could good for like using for in the specific tags and also with specific resources. And you also within 4 billion parameters, you can use on multimodal purpose. And also with 7 billion parameters of Lava, you can use it freely within your device. And also it have features for built on multimodal chatbot and also with OCR. And also for 5 family, we just released on 5.4 with 3.8 million parameters and also with multimodal 5.6 billion parameters, which is really small and compatible with our device. So lately, 4 days ago, Google DeepMind have been released on Gemma 3 in 4 billion parameters, and also it support for over 140 languages. And it's really brilliant so far. And it built from the big model and also it's become to distill into a smaller model. And you can see like multimodal process, and you can use it within the Llama, and you can input the image and let Gemma to analyze and bring it into the text. And also we have a lot of small language models that released in the previous months. All right, next is reasoning models. So how it differs from small language model? Actually, we can see that we have a prompt input and we have a fine-tuning of reasoning. So it could combine together and get the output, and then we get used to turn 1 into use in a turn 2, and also with turn 2 into the turn 3 will be a translated output, and we will call all of this process at the chain of thought-based fine-tuning for reasoning models. So reasoning in small language model, we could see like, or maybe large language model can be like in many types of reasoning. You can be on mathematics or maybe on like visual or maybe on the other tasks. And also for the open source list, we can see like DeepSeek are one really good on reasoning, and also we have a disk scale for 1.5 billion parameter as a preview. Also in Thailand, from SAP 10X, they provide you on Typhoon T1, which is based on Thai language, and you can use on reasoning models. Actually, they will get from open dataset and make a sampling and make the augmentation with the template that they give. So I will show you the template of it. So it will start with dots first. The dots will show the plan first, like the step 1, 2, 3, 4, 5, and then we will give you many steps. And since it's stop in step and it will stop in thinking process, and will be generated oral process together and give you a final answers. So how to use in sustainable ways? The first one is develop and use small efficient models by distilling, by using large language model. But try not to be on task specific, by the way. You can use on distilling step by step, and you could get the result that be smart and energy efficient. The second one is align model selection with specific tasks. You can see like there are key difference between language models and reasoning models. For language model, we could see like it's best for content creations and it come up with high hallucination rates. But if we go with reasoning models, it's best for scientific research and also with complex task accuracy and low hallucination rates. However, you need to make a considerations between using language models and reasoning models, because they will come with the price. Yeah, because if you like ask in the simple things like 2.2, it might compute in like many ways, because they find reasoning to process and think a lot to make sure that 2 plus 2 is 4. The third one is utilized in suitable model platform. I will show you in a 2 platform that can develop in small language model deployment. The first one is Olama, like Docker, but it's for LLMs, yeah. You can run within the command line interface, and then you can like just type in the terminal. And we can see like the inside architecture, we can bring the model from registry and also with the marketplace, and you could run in within the local machine, and we could like deploy in the other apps. But for LM Studio, it come up with UI, right? But seamlessly, we just see that we can't run any models within the terminal or command shell. Why Olama is better than LM Studio in development? As I said, it's run within the shell script. You can run within Azure shell or maybe like on Google Cloud shell, and also you can run within Google Colab. As you can see, like I need to install some kind of Colab terminal, and it will show up as an Xterm, and I could run like the single command line to install Olama, and it take not much time, and you could run and process your language model within Google Colab. And another thing is uphold responsible AI practice. I would say that we need to have responsible AI for using for generate the answers or generate the results, which is good and safe for everybody. And also, since we have responsible AI, we need to update into trustworthy AI, which is bring you to safety, security, and privacy. The next one is will be optimized model training and deployment. If you optimize it, will be good for reasoning price, and also it will be cheap and acceptable quality. If you're looking for open source fine-tuning framework, I would like to recommend to you the Onslaught. Onslaught would be the open Python framework that you can install it within Google Colab, and you can like training the model of fine-tuning from the data set from Hugging Face, and then you can use within the Onslaughts. Or maybe you can like deployment for helping you coding within the VS Code. So you try to install the extension of Continue and plug in with the API of Olama. You can download any models that help you on coding and install it in Olama, and Continue will bring the API from Olama and use within the VS Code. So if you would like to test something that I have been run in many events, so you can try it, and I will give the slides to you within the websites of FOSSASIA. And also the last thing is be creative to the world with models. In my side project, I use Lava, which is Large Language Vision Assistant, as my model for making my side project. So like I try to draw something like draw glasses or maybe draw a house. The Olama will bring the model's name Lava and interpret the thing that I draw. It's like some kind of neural network, but yeah, it's gonna be like generative in language model, and it will interpret as I draw glasses. It will show you as glasses. So I will show you something that really interesting. So actually, I will go to Google Colab that I did here. So if you would like to try on running in Google Colab, I think I would like to recommend to you if you would like to try on running the models. So I create the template of Olama in Colab, and you could run it. As you can see, you need to install the Colab Xterm first, and then install the library of Olama, and then you could run with it, and they have the structures of it. Oh, by the way, for Olama, something is very interesting for the base URL. For base URL, you can see the local host of 11434 is like is interpreted from the letters, which is LLAMA, which is Llama, as a model name. Yeah, this is quite a trivia, and also. I will come back to my key takeaways. Yeah, there are some key takeaways and also with world impacts. So what do we learn about this session so far? We can see like small language model could be bring to you on sustainability, which you could bring on a less energy and also could be more friendly. And also it's open source and ethical AI because it's bring to you on responsible AI practice and also with promoting on accessibility, collaborations. And also the last one will be efficient and creative AI. So you can optimize the workload and also you can enhance creativity. Also support innovation applications across industry. But in the future, it would be impact for the world by reducing the environmental footprint, and also there will be like democratizations of AI and also with enhanced efficiency of across industry. Even you can use within the educations or maybe on business. If you're not sure which model that you're going to use or which model would you apply, so I would like to recommend to you go to with GitHub models, try to compare themselves, try to compare between the models and models to make sure which model would best for you. And that's all for my sessions. Thank you for watching and hope you have a great day in the event. Thank you.
Yeah.
Any questions? Comments?
Is there any questions so far?
Do you know any, let's say, mobile application already can run small language model on mobile device?
Excuse me?
Do you know any, let's say, mobile application that can run the small language model on the mobile device?
Yeah, I would say if we run on Android, we will have an application named Private LLM. You can use to like try to download your SLM and try it on your phones. But I would say that if we try to run on a mobile phone, I would not recommend by the chance because it quite use a lot of resources to run and process the model and generate the answer. It's gonna be quite slow somehow. So maybe you may try like smaller model to run the models in your phone.
Further questions or comments? Well, not then. Please thank the speaker again.
Thank you.
Is the last speaker of the session around? Perfect. Do you have your own? I didn't find your presentation here. Do you have if you are not today, it's not going to update. No. I'll do it again, right? See? So I close. This one. Oh, this one. Yeah, okay. Okay. You can use either this or this one, whatever you want.
Can I start?
Speaker of this long session here, speaking about data mesh approach and MindsDB. Please welcome the speaker.
Okay. Hello, everyone. I'm Minh Lê. I'm happy to be here today at FOSSASIA to speaking about something that's the restepping, how we work with data, harnessing the power of decentralized data, data mesh approach with MindsDB and Ray. Okay, a little bit about me. I'm a founder of MyShift Vietnam Technology Solution, and it's the AI startup and focused on AI agent and multimodal. And now I'm working as a data solution architect at VP Bank. Okay, here is what we will cover today. We start with the big picture, the era of AI and decentralized data. Then we will talk about LLM challenges in data mesh. Next one is we will explore how Ray help in distributed LLM training and serving. Next one is MindsDB will help in real-time decision making on data mesh. After that, we will put it on together with the data mesh approach, and we will have a session for question and answer. Okay, we are in the new era. AI is everywhere, so the data is no longer confined to central warehouses. According to Gartner, over 18% of AI projects fail to reach production due to infrastructure and data challenges. Why? Because infrastructure and data is a big challenge. This highlights the critical need for decentralized operations. Okay, let's talk about this. You can see on the left we have a traditional centralized data platform. A data pipeline moves data from operational data plane to the central data warehouse or data lake. Okay, it's the bottleneck. You can see on the right, we see a decentralized data platform. This is the foundation of data mesh. Instead of one massive pipeline, we have a smaller pipeline. We have many smaller pipeline, domain-specific pipeline. This allows a greater agility and scalability. Okay, let's visualize the data mesh principle. The data mesh principle is built on 4 core principles. The first one is data ownership. The domain ownership. Domain ownership means that the team closest to the data, the ones who understand it best are responsible for it. So the second principle is data as a product. Data is not just a byproduct. Data is the valuable asset designed, maintained, and shared like other product. The third principle is self-serve data infrastructure. We need to empower domain team with the tools they need to manage their data product without needing to constantly rely on the central IT team on the company or organization. And finally, that's the federated computational governance. This ensures that while data is decentralized, we still have consistent standard and policy across the organization. Okay, now let's bring data mesh into the picture. Another statistic, only 26% of AI initiatives move beyond the pilot state. data quality and infrastructure are major roadblocks. Let's talk about LLM deployment hazard in data mesh. We need a consistent performance across the different data sources. We need the strong security and governance in decentralized environment. We need the efficient resource management for compute-intensive model, and we often have the expertise gap between domain team and AI specialists. The LLM mesh approach solves the challenges. It provides a common backbone for enterprise generative AI application. It offers a unified access to diverse LLM providers. It allows domain-specific context through vector store integration, and it maintains the centralized governance with decentralized execution. Okay, training large language model requires significant computational resources with costs that can only be afforded by trillion-dollar company. This is why distributed solutions like Ray are essential in this situation. Ray is the open source AI compute engine for scaling AI and Python applications like machine learning and LLM. Okay, why Ray? Because it's broadly compatible with any training framework, any cloud storage, or any compute platform. You can use Ray in AWS, in Google Cloud, or Azure, or in your own infrastructure. It's highly scalable. It's highly scalable, allowing you to easily scale out model training and data processing. It provides a built-in support for large language model with the feature like DeepSpeed or distributed checkpoint. And the last one is the one-stop AI workload optimized for unified framework for distributed computing or seamless scaling from laptop to your cluster. Okay, as you can see, the LLM infra before we deploy with a lot of tools like Triton, KFServe, Honeypot, or Airflow, and the LLM infrastructure in the slide was complex and heavily reliant on operation and Kubernetes. Okay, Ray simplify this. You can see how it streamlines the architecture, providing components for data processing, serving, and training, all while integrating with existing components. Okay. Now let's talk about MiceDB. MiceDB enables a real-time AI-driven decision making. It allows you to get insight directly from your operational database, improving decision-making speed by up to 50%. MiceDB offers a database native AI deployment. It has 100 data connector integration, and you can implement machine learning using SQL. Using SQL-based with MiceDB. It supports federated ML or MML LLM execution, which is crucial for data mesh. In the snippet code, you can see MiceDB enable direct integration for OpenAI, embedding with SQL database, streamlining vector operation on existing data through familiar SQL syntax. Okay, look at this. This is the LLM infrastructure before MiceDB. This is the typical LLM infrastructure It was complex with many moving parts and potential bottlenecks. You can see it's a very complex. And MySDB is simplified it. MySDB acts as a central point for interacting with your database and LLM, streamlining the entire process. Okay. By combining MySDB and Ray, we can create a powerful data mesh architecture. Data mesh architecture report 30% reduction on time to insight by decentralizing data ownership and improving scalability. As the MySIP Vietnam, we build a scaling enterprise AI based on MySDB and Ray. When a user interact with an enterprise chatbot, you can see MySDB efficient process the query, retrieve contextual relevant information from the knowledge base, and coordinate with Ray for distributed model inference, delivering an accurate context-aware response. By integrating RISE and MyDB in unified architecture, organization can create a powerful data mesh optimized for AI application. RISE, you can see we have a RISE layer in the bottom. RISE delivers distributed computing capability for LLM training and serving. MySDB bridge domain data resource with LLM. A federated governance layer orchestrates the entire ecosystem. You can see this component on the bottom. This architecture empower organization with autonomous domain team, enterprise-wide knowledge sharing, seamless scaling for increasing data complexity and accelerated AI deployment. The combination of AI of data mesh, Ray, and MyDB create the AI system that are fast, scalable, and domain aware. This way, we'll be building a foundation for next-gen enterprise AI. Okay, that's all. Thank you for the attention.
Any questions, remarks? Everyone is tired from the long session, I have to say. we are the last ones, everyone. I think everyone else has finished, so. No questions, remarks, details?
Query and MyDB?
Sorry, my question is that what kind of data you store in MyDB,
okay.
and what kind of query I can execute on MyDB?
Okay, MyDB here acts as the connector between your domain data. Like here, you can use MyDB as the connector its own and using RISE for serving LLM and training with the domain data in this architecture. Okay.
Any further questions? Well then, let's thank the speaker again. Thanks everyone who stayed here till the very last talk. This closes the session today, and we are starting the conference tomorrow morning, 9 o'clock. Please also don't forget, we have the social event for those who got a ticket later tonight here in this area. Thanks a lot, everyone. Have a nice evening.